Hi, welcome to MACSGATE. So let us continue the second chapter in DBMS, which is relational model. What is a relational model? Hi, welcome to MACSGATE. In relational in relational model, data must be stored in tabular format. So first we need to decide what is our table name. So the table is the object or the collection of objects about which we want to store the information. So here in our example, I want to store the details about the students. About the students, I want to store the details. Now the question is, what information we want to store about students? That we need to decide. So about students, I want to store SID, student ID, and similarly S name, student name, and age of the particular student. Like that, we need to decide what are the properties we want to store about the particular object. These are called properties in general English. Technically, they are called attributes. Technically, they are called attributes. So, in relational model, the data must be stored in the table format. So, first we need to decide what is the table name. The second one is we need to decide what are the columns, that is the properties we need to store about the particular objects. So, let us discuss the basic terminology of the relational model. The first one, relation. In simple English, a table is a relation. This is an example of a relation. So, in Hobbes concepts, we can say a table is an object, or we can say it's a class about which we are storing the information. For every object, we will store the properties or the characteristics, which are, in our case, they are called attributes. Now, the next one is record. What is a record? A table consists of so many rows. Each and every row is called a record. Each and every row is called a record. That is the details about a particular object. In our example, we are collecting the information about the students. So if I give the details about a particular student, then that will be called as a record. For example, in this case, suppose I want to give the details about the student Lakshmi. Then what are the details, sir? The ID is 11 and the name is Lakshmi and the age is 30. So this is called a record. Mathematically, this is a row of the particular table. Is that fine? Then attribute. As I said, attribute is a property. Is a property or characteristic about the particular object. So about students, how many properties you are going to save? In our example, we are collecting the information about IDs. Similarly, we are collecting the information names and age. So these are the properties or attributes or features of the particular object. We want to store the information about the students. Is that fine? The next one, arity or degree. Degree is the number of attributes of the given relation or table. The number of attributes or simply you can say the number of columns of a particular relation. In this example, can you give what is the degree of the particular relation? In this, we are having 3 columns. So the degree of the particular relation is 3. The next one is cardinality. The number of records which we are having in our particular relation. The number of records, or mathematically the number of rows of the particular table, is called cardinality. In our example, how many rows we are having, sir? 1, 2, 3, 4, 5. So in this example, what is the cardinality? The cardinality of the relation is that fine? The next one is relation schema and relation instance. What is relation schema? The structure of the table without any particulars of the data is called relation schema. In this example, what are the details of about the particular table? The table name is student. The table name is student. What are the attributes you are storing? The first attribute is SID, and the second one is SName, and the third one is age. So here we don't mention any particular record. It is the skeleton of the relation, the structure of the table which we are going to store in our database is called relation schema. In relation schema, we don't mention the properties of any particular record. That means in this case, we don't mention the properties of any particular student. That may be Sudhakar or Lakshmi or Sita. So that is relation schema. What is relation instance? If we consider relation schema, if we consider a relation schema along with the data, if we consider the relation schema along with the data is called relation instance. In this example, if we consider the entire table, so if we consider the entire table, that is relation instance. Now one important note. Okay, what is meant by schema? Suppose we are having a institute. We are having a institute, and at the beginning we will design an application which should be filled by every new joinee in our institute. So in application form, we give one title, that is our relation name, and the columns are the rows, that is the details, detail 1, detail 2, detail 3. This is the skeleton of the application form. Here I don't have the details of any particular student. So the structure or the empty copy of the application form is called relation schema. Now suppose I have the collection of applications in which I have the details of the students. That particular collection is called relation instance. Is that clear? The next one is null value or domain. Null value and domain. What is null value and in which situation we want to use it? Suppose a student entered only 2 details of him. Suppose the roll number or ID is 55 and the name is Sudhakar, and he not entered his age. Whenever the student not entered his age, what should we do? Either we need to call back to the student and we need to ask his age. Then Till then, what should I fill in that particular entry? So in that particular entry, we can fill, there are two possibilities. The first possibility is we can fill null values. Null values means we don't know the value of the particular entry. Instead of null value, we can place some default value. Since we are collecting the ages of students, you may place on an average some 25 or 30. So that depends on our requirement. In generally, if we don't know what to place as a default value, people use to keep null values. Since I don't know the values of age of Sudhakar, we will keep null value. Suppose we have a student whose name is Sita and her age is 18 and she don't know her roll number or ID. Then in such case we fill null value. So null value means we don't know the value of the particular entry. In such case we use null value. Simply we can say it is used to denote unknown value. To denote unknown value. Null value means it is not known. Then the most important one, domain. What is domain? Let me give the definition. The set of all values which we consider for a particular attribute. The set of all values which we consider for a particular attribute. Suppose for student ID, I want to collect all integers. For student ID, I want to collect all integers. So the collection of all integers is my domain. Similarly, for student name, suppose I can write any string which is made of English alphabets. Then the collection of English strings is my domain for the attribute S name. Similarly, age. So whenever we create the table, we mention the table name and the attribute names and the domain from which we can allow the values to be placed in the particular entries. So that is about domain. So let me give the basic SQL command with which we can create a table in our database. Suppose we are creating the same table. We are creating the same table student with attributes SID, SName, age. So this is the table which we supposed to create. Then what is the basic SQL command to create this table? Create table. Create table. These are the two keywords. Then what is the table name? The table name is student. The table name is student. Now we need to specify. We need to specify the attribute names or the column names. What is the first attribute? SID. And for SID, we are assuming that or we want to take only integers. Then I should know the keyword to specify integers. Like in our C language. In C language, what is the data type or what is the keyword for integers? The keyword is int. Am I right, sir? Like that in SQL, we are having some keywords to specify the set of integers. In general, the people will use number of some integer. So what is the meaning of number of 4? Number of 4 means I can consider any integer which can have maximum of 4 digits. Suppose the user has given 8942. It is allowed. Suppose the user wants to give 435. It is having maximum 4 digits. It is also allowed. Suppose now he is supposed to enter some value 49,525. Here I have 5 digits. So this is not allowed. That is the meaning of number of 4. Instead of number of 4, depending on the software you are using, you can write integer also. By looking at that command, you can understand what the intention. As of now, let us use the number. So number is the keyword which is used to specify it is a integer, and I am assuming that the student ID can be of maximum 4 digits. So that is about the first attribute. What is the second attribute? The second attribute name is S name, that is student name. So we are assuming that the student name is a string. In C language, how to specify the strings are? So we can specify by writing like char x of 20. So that means it is a string which can have maximum of 20 characters. Instead of that one, in SQL, the keywords are either we write char of 20, or one more frequently used word is varchar 2 of 20. We discuss all these details in detail in SQL, sir. As of now, let us assume varchar 2 or char of 20. These are the two keywords to specify the strings, and 20 is the maximum length of the string, that is allowed. So here we will write varchar 2 of 20. What is the third attribute name? The third attribute name is age. Then how to specify age, sir? It is same as integers. So let us write the keyword. What is the keyword? The keyword for integers is number. Then what is the number we can write, sir? Maximum a person can live 100 or 150 years. He cannot live more than 900 years, right? So we can have maximum of 3 digits. Of course, 100 is also not possible in these days, but the maximum will be 100 or 150. So that's why we write this one. So whenever the user will give some number 154, there is no issue. Suppose he wants to give 4152. It is not possible. So these two are not allowed. This is the basic SQL command to create the table with the corresponding attributes and the domains. So in this, we specified 3 things, sir. The first one, table name. So whenever you are creating, sorry, let me write it here. Whenever we are creating a table, we need to specify what is the table name. The second one is attribute names, and the third one is domains of the attributes. Hope I am clear in these 3. So this is at the time of creation we decide, and this will decide the schema of the particular relation, which is called relation schema. Is that clear? So let me give one more data type. So when coming to domains, I already introduced to 2. The first one is for integers. For integers, what are the possibilities? Either people will write integer of some digit. So let us have integer of 4. Similarly, number of 4. Instead of 4, we can write any digit, sir. There is no issue. Similarly, when coming to the second one, strings. So in strings, people may write char of 20 or where char 2 of 20. Then what is the one more data type which we frequently use in our regular type? That is real numbers. In C language, they are called float. Now the question is, what is the keyword to specify the attribute is a real number? So for that we write number of 10, 2. Not only 10, 2, sir. If you want, you can write 5, 3 or anything. Now let me explain what they mean. The first one is total number of digits. The first one is total number of digits. What about the second one? The number of digits after decimal. Number of digits after decimal. These are the three frequently used data types in our SQL. Am I clear up to here? So let us continue to the next one. So let us solve one of the previous question. Just go through the question, sir. Which one of the options given below refers to the degree of a relation in relational database systems? The first one is number of attributes in a relational schema, number of tuples stored in the relation, number of entries in the relation, number of distinct domains in the relation schema. What is the answer, sir? The number of attributes of the relation is called degree. What is the number of tuples called? The number of tuples is called cardinality. So the answer for this question is the number of attributes in the relation is called degree of the relation. Is that clear? Now let us discuss relational constraints. When we are creating relations in a relational model database, we need to follow some set of rules and regulations. Constraints, in simple words, they are rules. Rules are conditions which we supposed to follow when we are creating relations in relational model. So that is called relational constraints. The set of all rules that are to be imposed. The set of all rules that are to be imposed on the database to validate the quality of the database. What are the constraints? There are mainly 4 types of relational constraints. The first one is domain constraints. The second one is key constraints. The third one is entity integrity constraints. And the fourth one is referential integrity constraints. In this session, let us discuss the first two. The remaining 2 constraints we discuss in the next session. So let us complete the first 2 constraints. What are those? Domain constraints and key constraints in this session. So the first one is domain constraints. In domain constraints, we are having mainly 3 rules. What are those 3 rules? The first rule is we can restrict the value of an attribute to be the set of characters or set of integers, etc. For example, suppose we are having a relation and let us assume we already decided the domain for student ID is int. At the time of creation of the relation, we specify what is the domain for that particular attribute. So let us suppose that we decided integers is for SID and strings is for name, int for class, and age is also integer. So these are the domains we already specified when we create the table in the database. Now suppose I want to enter a new student whose ID is 5 and whose name is Sita and her class is third class. Now her age is 20. So here I supposed to write 20. Instead of writing like this, suppose we written like this. Sir, our intention is same 20 only, but the software at DBMS cannot understand the 20 in numerical format. You specified the value should be entered in the form of integers, but you entered the value in the form of strings. So it don't consider the not syntax, semantics of the particular entry. It will consider whether it is an integer or not. So here if you write like this, it is not allowed. Compulsorily we need to write 20 only. Similarly, suppose in the class I supposed to write 4, but instead of 4, because of my mathematical knowledge, 4 and 4.0 both are same. Of course, 4 and 4.0 both are same, but at the time of creation, we promised that the values of the class are integers. So we should not violate that particular rule. So we can restrict the value of an attribute to be the set of characters or the set of integers. This is our first constraint. Let's go to the next one. Composite attributes are not allowed. Only simple attributes are allowed. Composite attributes. First, let me explain what is meant by composite attribute, what is meant by simple attribute. Suppose let us consider the same table relation. Here I want to store the roll number of the particular student and name, but name I want to collect in two parts. The first one is first name, the second one is surname, and the third column is age. So my intention is name should consist of two parts. If I draw this table on a white paper, easily or without any hesitation we can draw it. But whenever we create a table or a relation in relational model, this is not allowed. This is an example of a composite attribute. Composite attribute. So what is meant by composite attribute? An attribute which is divisible, is having some subparts or some parts of the particular attribute. So here the name is having two parts. The first one is name, first name. The second one is S name. So this type of composite attributes are not allowed. What is meant by simple attribute? What is meant by simple attribute? Suppose I said roll number. It is either 1, 2, 3, so on. It is indivisible. We cannot divide further. So this is an example of a roll number. Similarly, age. What is your age? 40, 30, 20, 40. So it is also indivisible. So the attributes which are indivisible are called simple attributes. The attributes which are further divisible are called composite attributes. So when we create a relation, composite attributes are not allowed. Only we can allow simple attributes. So suppose my intention is this one only. I want to create roll number or student ID and name which is having two parts. The first one is F name, the second one is surname and age. According to domain constraint, this is not allowed. then what should I do? So consider these two columns as individual columns. Consider first name and surname as independent columns. Then we create the table like SID, first name, surname, age. So in this case, they are independent columns. They don't have any relation. So they are simple attributes. Is that fine? The next constraint is multi-valued attributes are not allowed. Multi-valued attributes are not allowed. What is meant by multi-valued attribute? What is meant by multi-valued attribute? Okay. For example, if someone asks, what is your age? Then you will give only one answer, either 42 or 43 or 23. So I will have only one answer. Suppose if someone asked, what is your Aadhaar number? Then also you will give only one answer. Am I right, sir? Now suppose somebody asked, what is your mobile number? In these days, so many people are having more than one mobile number. So automatically I will get multi answers. It doesn't mean that every student or every person will have 2 or 4 numbers, but there is a chance of having 2 or more phone numbers. So these are called multi-valued attributes. So whenever there are more than one possible value for the given attribute, that is called multi-valued attributes. In relational model, multi-valued attributes are not allowed. Then what should we do? I want to consider mobile number only. Then how to overcome this constraint? So suppose I want to give student SID, name, let us suppose the third one is mobile number. Whenever I have a column, here I should not write my first mobile number is so and so and my second mobile number is so and so, because multi-valued attributes are not allowed. So for this one, there are so many possibilities which we discuss in normalization. Here let me give one possibility with which I can store the mobile numbers even with multiple answers. So for that, student ID, name, and we will impose a maximum cap on the number of phone numbers. Suppose I am assuming that a person can have maximum 2 phone numbers. Then I write mobile number 1, mobile number 2. So that depends on your requirement. Suppose you are feeling that everyone will have minimum 3 phone numbers. Then you may add one more column, mobile number 3. So like that, this multi-valued attribute is split into 2 or more attributes. Now mobile number 1, surely people will give the first mobile number. Similarly, mobile number 2, he will give the second mobile number. So it is not a multi-valued attribute. Is that clear? So this is about the domain constraints. Now let's go to key constraints. What are key constraints? No 2 records in the table are same. No 2 records are same. What does it mean? That means no 2 tuples in the relation should have same value for all attributes. Suppose I have 2 students in my class. Then I ask their roll numbers. And I ask their names, their age, their class. Then those 2 students should not give same answer for all the values. At least one value, that means one attribute should have different answers. Their names may be same, their class may be same, their age may be same, but at least their student ID must be different. If 2 students are having all same details, how can I differentiate between those 2 records? So according to key constraints, no 2 tuples in the relation should have same value for all attributes. For example, suppose I have a relation like this, 1 Lakshmi, 1 25. So let us focus on this record. So I have a student Lakshmi whose ID is 1, whose class is 1, whose age is 25. Now I can have one more student whose name is Lakshmi, whose name is 1, whose name is 25. Suppose you mention ID also 1, then this is not allowed because the first record and the new record, both are having same values for all the attributes. At least there should be at least one column in which they are having different answers. That means Lakshmi, class, age, at least ID. Suppose the ID is 7, then fine, no issue. So they are having two different values for the attribute SID. That's the meaning of it. Please check it, sir. They should not have same value for all the attributes. They may have same value for some of the attributes, but not for all attributes. This is about key constraints. Now, what is meant by key? Key is a general terminology which is used to denote any type of key, sir. So then first let me give what is a candidate key or what is the meaning of key. Okay. First of all, what is a key? Key is the set of properties with which we can identify the particular record uniquely. Key is the set of properties or attributes with which we identify the records uniquely. Suppose we consider the student's example. What are the properties you need to identify a student uniquely? Suppose I want a student whose name is Sudhakar. Then if I give only the name, whenever I went to a class, if I mention the name, there may be more than one student with the name Sudhakar. So name is not sufficient to identify the students uniquely. Am I right, sir? Similarly, suppose I given name comma age. Our name is, the student name is Sudhakar and age is 20. There is a chance of having two or more students with the same name, same age. So with only name, it may not be possible to identify the records uniquely. Similarly, with name comma age, it may not be possible to identify the students uniquely. Of course, if the students are having some registration numbers or rule numbers or IDs, suppose SID or you can say rule number or registration number, then if I call who is rule number 22, only one student will respond because in a class the rule numbers are distinct for each and every student. That is the intention or meaning of key. So key is the set of values with which if I announce in the class, only one student will respond. Then what is meant by candidate key? What is meant by candidate key? So as our assumption, whenever I mention who is rule number 22, whenever I said that who is rule number 22, only one student will respond. Something like, suppose parents came to principal office and they asked about their son's details. So they given the rule number 22. Then with the information 22, we can call the student uniquely. Now for safe side, the parents given that ID comma name. So they said that 22 is my son rule number and his name is Sudhakar. So whenever I know these two details, I can identify the student uniquely. Of course, only with the 22 it is possible to identify. Then why not with two details? Yes, of course, it is possible. Suppose they are given three details. Student ID, name, comma department. So 22, Sudhakar and CSC. So this also we can do it. Now any one of these three is called a key. Any one of these three is called a key. Then what is meant by candidate key? That is what we are going to focus mainly. What is a candidate key? Minimal set of attributes. Minimal set of attributes which can be used to differentiate the records of the table, or we can say to uniquely identify the records. So we have discussed what is the meaning of uniquely identifying records, or what is the meaning of differentiating the records. Now the main question is, what is the minimal set of attributes? What is the minimal set of attributes? Now with this also I can identify, with this also I can identify. Now the question is, are these two mandatory to identify the student uniquely? Or both are compulsory, sir? No. Even I can do the same job without having the attribute name. So this is not mandatory or not compulsory. Is that clear, sir? So this is not a minimal set. The second one is not a minimal set. Whenever I consider the first one, of course I have only one. So automatically it is mandatory. So this is minimal set of attributes. So this is the meaning of minimal. Now let me give one more small example. Suppose the same students we have considered in a college. Sir, in college almost all the students are having different roll numbers irrespective of their class. So in college I can say student ID is enough to identify the records uniquely. Now instead of college, suppose let us consider a small school which is our nearby home. Then in general in schools in every class students will have roll numbers 1 to 30. 1 to 30. Now a parent came and asked, sir, I want to talk with my son. Then principal will ask, what is the roll number of your son? So suppose he said 5. So his roll number is 5. Can you identify the student with roll number 5? No, sir. Because in first class we may have student with roll number 5. In second class we may have. In third class we may have. So that means we are having so many number of students with same roll number. Then in this school to identify the record, compulsorily I need to give the class name. So suppose I said the roll number is 5 and he is third class. Then we go to third class and we will ask, who is roll number 5? Who is roll number 5? One student will respond, sir, it's me. So we are able to identify the record uniquely. Now the question is, to identify the particular student, minimum how many details you need, sir? I need compulsorily roll number. I need compulsorily the class. Suppose I have only roll number. Is it possible? No. There are 10 classes in which I have 10 5 roll numbers. So it's not possible. Suppose I know only class. He is in third class. Can you identify? No, sir. In a class, there may be more than 30 students. So only with ID it is not possible. Only with the class it is not possible. So compulsorily I need ID, comma, class. These two are mandatory. Now, in addition to these two, suppose the parent has given ID, comma, class, comma, name. Can you identify? Yes, of course. With ID and class only we are able to identify. Then why not with 3? So both are keys in our school example. But the second one is not minimal because without name also we can do the work. But whenever I come to the first one, even I miss any one of them, I cannot do the job. That is the meaning of minimal. Sir, minimal means it is not one. In that collection, everyone is important. If I miss any one of them, I cannot continue the job. That is the meaning of minimal set of attributes. Suppose let us consider the regular example which we already very famous. In this example, suppose I given Aadhaar number. I given Aadhaar number. Suppose I said that some XYZ so on some number. How many persons will respond, sir? Only one person will respond. So whenever I know Aadhaar number, I can identify the person uniquely. So this is an example of a candidate key. Of course, whenever I have only one attribute, it is a key, surely it will be a candidate key. Because I have only one, it is mandatory. If I have 2 or more, then there is a chance of it is not a candidate key. But whenever I have only one, surely it will be a candidate key. In this case, suppose we return name. Can you say this is a candidate key? No, sir. It may be minimal, but it may not be enough to identify the persons uniquely, because there may be so many persons with the name Sudhakar. Am I right, sir? Suppose I have name comma age. Name comma age. Can you say this is a candidate key? No, sir. Because there may be so many persons with these two attributes. Is that clear? Suppose I consider one more. What? Is it a candidate key? Yes. Now, can you answer this question? Suppose I have Aadhaar, comma, city in which he is living. Now the question is it a candidate key? No, sir, because it is a key, but it is not minimal. It is not minimal because city is not mandatory, but it is a key. Sorry. So hope you understood the definition of key and candidate key. Sir, key is a general term with which we can identify the records uniquely. Among so many possible keys, candidate key is one key with minimal set of attributes. Hope you are clear about candidate key. So, how to identify the candidate keys? How to identify the candidate keys for a given relation? The first one is with assumption. With assumption means like whenever we have knowledge about the attributes, like the example Aadhaar number. How can you say Aadhaar number will identify the person uniquely, sir? That is the assumption was made in India, right? So this is the example we have done about the Aadhaar numbers, right? The next one is with instance. Generally people don't use sir, but if I consider at that particular point of time and if I restrict, this is the only data I am having in my relation, we can say this is the candidate key for that particular relation. But generally we don't go for this particular method with instance. And the next one is with the help of functional dependencies. We are having a big story like Bahubali about functional dependencies that we discussed in a separate class. What is a functional dependency? How to identify functional dependence, how to identify the candidate keys using functional dependencies. So these are the three ways to identify the candidate keys. So with assumption, we already given one example, sir. So whenever we discuss about Aadhaar, PAN, like this, the attributes about which we are having some knowledge. So that is candidate key. Or the best example is college and school example. Sir, whenever we go to college, something like an engineering college, if I know the roll number of a student, this is enough. This is a candidate key. But the same roll number, if I consider in a small school, the roll number may not be enough. In addition to roll number, I need to know the class of the particular student. So in such case, we are having candidate key. Then who said that class is mandatory? I am assuming in my school, I need to know the roll number and class. That is with assumption. With instance, how to identify with instance? Okay. So let's make a small example. Suppose I have a relation with three attributes A, B, C. I am verifying whether this is a candidate key or not. Why are you trying with A, sir? You can try with B also. You can try with C also. Why don't you try two attributes? Since candidate key is a minimal set, first I try with one attribute. If there is no candidate key with one attribute, I go for two attributes. First let us try it. In this, verify whether there are any duplicates in that particular column. A1, A6, A2, A4, A2. That means row 3, row 5. Sir, this is my first row, second row, third row, fourth row, fifth row. So row 3, row 5, both are having same values. So if I call who is A2, who is A2? How many records are responding, sir? 2 records are responding, but only 1 record should respond. So this cannot be a key. Similarly, if I consider B, please verify all the values are distinct. All values are distinct. So whenever I call with some B2, only 1 record will respond. Suppose if I call with some B4, only 1 record will respond. So this is a candidate key. First of all, it is a key, sir, and since it is having only one attribute, we can say it is a candidate key. What about C? C1, C4, C3, C5, C2. So all are distinct. It is also a candidate key. Is that clear, sir? Now the question is, can I say this is a candidate key? Sir, if I consider the values A1, B1, A6, B2, A2, B7, A4, B3, A2, B4, all are distinct, but it is not minimal. It may be a key, but it is not a candidate key because it is not minimal. In this, B is mandatory, A is not mandatory. Hope you understood the definition of candidate key. Let us do one more example. Find the candidate keys for the following relation. The first one, can I say this is a candidate key? Please verify, sir. I think this is row 1, 2, 3, 4. A1 repeated. A1 repeated in row 1, row 2. So this is not a candidate key. What about B? B1 repeated in row 1, row 3. Then what about C? C4, C8, C2, C5, all are distinct. It is a candidate key. Then can you try with this one, sir? Yes, of course, we can try it. We can try this because no one of them is a candidate key. What about this, sir? If I consider as pairs A1, B1, A1, B2, A2, B1, A2, B2, A2, B3, all are distinct. All are distinct. So it is also a candidate key. Now the question is, can you say this is a candidate key? No, sir, because C itself is a candidate key. So this cannot be minimal. Since it cannot be minimal, it cannot be a candidate key. Is that clear? So you can do the same process for this example, sir. Hope you can do this one. So let us leave that as a practice exercise question. First, we need to do A, B, C. Then let us consider 2 attributes. Then 2 attributes. Like that, we need to continue. Please do it, sir. So now let me give the properties of the candidate keys. We have already discussed it, sir. Just let me list out the properties what we discussed. If X is a candidate key, then no 2 records are having same values. Sir, if it is a candidate key, only 1 record will respond. If 2 records are having same value, 2 will respond. That means candidate key is not a key. Candidate key, first of all, it is a key. You should identify the records uniquely. The next one, if X is a candidate key, proper subset of X should not be able to differentiate the records. Suppose I have A, B, this is a candidate key. Then if I consider only B, it should not differentiate the records, because if it is able to differentiate the records, B is not mandatory, right? Whenever B can do the work on its own, why I need A? Whenever I use this is a candidate key, both are mandatory. So no proper subset can do the job on its own. A relation can have more than one candidate key. A relation can have more than one candidate key. Like we have seen in the previous example, I have a candidate key with C and I have a candidate key with AB. Okay. Even this is the example which I given as a practice in the previous slide, and you can verify the candidate keys are AB, BC. Please check it. So that is about the first two constraints in relational model. In next session, we will discuss entity integrity constraints and referential integrity constraints. Thank you.